In this video, I will show you what happens when you add a resistor to this simple circuit. So I'm gonna cut here, and I will add a resistor. So the way that I will do that, this is one way of effectively making a resistor. Decreasing the area of your wire. So as I mentioned before, okay, if you do an experiment, this is important, the experimental result. If you do an experiment with this circuit where you have one piece of a wire that is thinner, smaller cross-sectional area than the rest, you will still find the current to be the same everywhere throughout the circuit. And this makes sense because the electrons will never accumulate anywhere. Okay, they will not pile up, keep piling up as time goes by. If you make a cross section here and you count how many electrons pass per second, you will find the same number here and here and here and everywhere throughout the circuit. So experimentally, the current is the same everywhere. If I is the same and the area decreases here, this means that the electric field needs to increase to compensate for that. So for an electron that is here, this electron in this very thin wire, it will need to experience a much greater electric field than what it does in the rest of the wire. Now, to have that increased electric field here, the way that we can accomplish that is by having a greater difference between the surface charges here and here. Let me show you how we can accomplish that. So when I'm comparing this point of the wire and this point of the wire, I see a difference of 1. I have 3 here, I have 2 here. Between this point and this point, there is also a difference of 1. Between this point and this point, there has to be a difference of 1 as well in order to maintain the same uniform electric field in this wire with the same thickness. When I arrive though at the difference between this point and this point, it needs to be greater than 1. For example, how can it be greater than 1? If you place 1 minus here and 1 plus there, then you get a difference of 2 because you have plus 1 minus 1. The difference here is 2. Now if you look at what I just did, there is a plus, there is a minus. Between this point and this point, there is a difference of 0. So I'm gonna do this. There is a difference of 1, a difference of 1, a difference of 1. That's why the electric field here has the same strength. When you go from this point to this point, there is a difference of 2, which is consistent with a greater electric field in that thin part of the wire. And then I go, I need a difference of 1 here everywhere in this part of the wire. So I have 1. This means I need to get 2 pluses here, 3, 3, 4, 4. Now the difference is 1, 1, 1, and again I'm back to 2. So this is what happens when you add a resistor in your circuit. The electric field in the resistor will be much greater to compensate for that decrease in the area. And this is one simple model of a resistor. Okay, actual resistors probably don't use just a decrease in cross-sectional area to work, but this is a simple way to make a resistor. Just cut the cross-sectional area of your wire by a lot, and then you're gonna have a simple simple resistor